Okay, pre-cal babies, in this video we are going to do more examples of simplifying our trig expressions down to a single term. So number 12 here, we have sine theta over cosine theta and cosine theta over sine theta. We can't transform any of these into something that's going to be useful. We could change sine and cosine into 1 over secant, or 1 over cosecant and 1 over secant, but that's just going to give me a compound fraction and nobody needs that. So the first thing we're going to focus on here is finding an LCD so that we can combine these fractions. So of course my LCD has to contain both cosine theta and sine theta. So I am going to rewrite my problem here. And I'm going to multiply each side by what's missing in the denominator. Okay, so here I end up with sine squared theta plus cosine squared theta all over my LCD. All right, and then what I can do once I've got one fraction here, this right here can be replaced because it is one of our Pythagorean identities. Right here, if I've got sine squared theta or sine squared x plus cosine squared theta or cosine squared x, those can be replaced with 1 because they're Pythagorean identities. So I'm going to replace this. And of course we want to eliminate our fractions. So because this can be written this way, I can replace those. You'll notice on our identities page, oh, I circled the wrong ones. I can replace 1 over sine with cosecant and 1 over cosine with secant. So I've got secant theta, cosecant theta. We got one term, no fraction, no addition and subtraction. Life is good. Okay, on number 13, we're going to do the exact same thing, because we can't replace 1 plus sine theta or 1 minus sine theta with anything. Anytime you have sine and it's not squared and it's added to 1, you can't do anything with that. So we're going to create our LCD here. It needs to have a 1 plus sine theta and a 1 minus sine theta. So I've got to rewrite my problem here. And then, of course, I am going to multiply both sides by the part of the LCD that's missing. And then, of course, I am going to simply multiply that. So 1 minus sine theta times 1 is 1 minus sine theta. 1 times 1 plus sine theta is 1 plus sine theta, all over my LCD. Boy, my handwriting is horrible. Okay, so I'm going to combine like terms. This 1 and 1 becomes a 2. Negative sine theta and positive sine theta add to 0. So in my denominator now, I am going to FOIL this. So I get 1 minus sine theta plus sine theta minus sine squared theta. So combine like terms again, those add to 0. And then I see that sine is squared here, so I'm going to go back to my identities sheet, look at my Pythagorean triples, check it out. Pythagorean theorem identities, sorry. So I can replace 1 minus sine squared theta with cosine squared theta. So 2 over cosine squared theta. So another way to think of this is this right here. And if I've got, you could write it separately that way if you wanted to, because 1 over cosine, of course, is secant. So I've actually got 1 times secant theta, which is 2 secant squared theta. Awesome.